Okay, so getting a little slightly more into the introductory material. Astronomy is actually a very vibrant field. I mean, you might think of it as being sort of a very ancient field and think about just going out at night and looking at the stars through a small telescope or something like that. And when you look at the stars through a small telescope, things don't really change that much. It's a pretty fixed sky. When you look at the sky through a small telescope, you basically see the same sky that Galileo saw when he first used a small telescope. He was the first person to use a small telescope to look at the sky. So based on that, you might think things are kind of static, but if you read the news, there's actually new discoveries in astronomy all the time. There's just so much out there that we don't understand. It's pretty incredible. It's really incredible that we're able to live as comfortably as we are on this little rock floating around the sun. I mean, you can sort of live your life completely oblivious to the greater universe out there, but if you stop and think about it, it's pretty awe-inspiring that we're just able to survive here. I mean, in the midst of the titanic forces that are taking place all over the universe, fortunately not too close to us. But I mean, there's many, many places in the universe where life can't exist, that's for sure. And we have this wonderful little tiny oasis, which is, I mean, to say that it's microscopic compared to the universe is like the understatement of the century, because it's beyond microscopic. I mean, the universe is just so much bigger than anything we can think about on the Earth. We'll talk about that. Actually, I have a little video that kind of tries to show you the size scale involved in the universe. That it just makes the Earth that much more special, I think. My contacts are doing weird things, or else the projector is acting. But anyway, if we plot this is sort of just a rate of discovery, just a kind of a rough idea of what's been stimulating new developments in astronomy and new discoveries. And what we find is, if we go back to the earliest times that we treated in this course, that's the time of Galileo, the time of Copernicus, there was a tremendous uptick in discoveries, mainly because Galileo not only invented the telescope, but also started to work out the laws of motion, some thinking about the laws of motion and the development of scientific rational thought. That's in the early 1600s. And then we have, of course, the Einstein spike in the early 1900s, when Einstein developed both special and general relativity and started to give us our first glimpse of the larger universe in terms of what the scales are really like again. We're kind of where we really fit into the universe. You need to have relativity theory because that actually basically gives us an idea of how sort of weak gravity is around the Earth compared to how strong it is around some of these massive, massive objects that are out there, like black holes and things like that. They're incredibly far away. And you can't really grasp that without this idea of relativity, which gives you this idea of comparison between objects. Then we go forward, and these are just very rough markers, but the Hubble Space Telescope around 2000, again, revolutionized scientific thinking. I mean, there's a few specific photos, which I think I have a few of them in my slideshow here, that Hubble made, which were just completely, again, completely revolutionary. Like, for example, they took a shot of a region in the Big Dipper. You've heard of the Big Dipper? Who hasn't heard of the Big Dipper? Try to admit it. Well, it's up there. It's Ursa Major, the Big Bear, also the Big Dipper. But anyway, actually, it's a pretty boring part of the sky. If you look toward the Big Dipper, you see the shape of the Big Dipper, but you don't really see a lot of stars around there that are dimmer stars. And it so happens that when you look at the Big Dipper, you're pretty much looking up out of our galaxy, which is kind of pancake shaped. So it's considered to be a pretty boring region. But when Hubble trained its optics on that region for a whole week, just looking into that region, it was able to see things which I don't think it's necessarily in the next slide, but anyway, it's in here somewhere. Tiny galaxies forming at vast distances away from us, incredible periods of time in the past. Because when we look into space, we're also looking back into time, because of the time it takes light to travel. So we'll talk about that more later. The Webb telescope coming in a few years is we have Spitzer, which is an ultraviolet, infrared telescope, which has revolutionized that region of our observational capabilities. I talked about how different wavelengths teach us different things. That's a non-visual wavelength that we talked about with Spitzer, actually ultraviolet. And then Webb is going to be like a super version of the Hubble Space Telescope. Okay, so the Hubble Space Telescope has a diameter of about 3 meters or so. It's the biggest astronomical telescope ever launched into space for astronomy purposes. There's probably bigger mirrors up there in space, but they're actually spy satellites. It's pointing down at the Earth. But this is the largest mirror in space right now that's being used for astronomy purposes. And it works incredibly well because it's above Earth's atmosphere. So that the twinkling phenomenon that we see when we look at the stars at night is actually due to aberration in Earth's atmosphere, and it messes up photos and things. You can imagine if you zero in on something and it's twinkling, it's actually moving around a little bit, and you try to take a photo, and that blurs and messes up the photo. The Hubble in space completely avoids that problem. The Webb, you can see, is vastly larger than the Hubble, and it's going to launch around 2018, and I mean, it's impossible to really even speculate about how revolutionary that's going to be, because you don't know what you're going to discover, right? But it's going to allow us to look to greater distances, because it collects so much more light, we can see different things, right? And different things are usually farther away. Things that are farther away are being seen farther in the past because of the light, the time it takes light to travel. So with the Webb telescope, we'll see closer and closer to the beginning of the universe, which started as a Big Bang about 13 billion years ago. Okay, so I usually like to go over a few kind of recent developments in astronomy just to highlight that, yeah, there are actually new things going on in astronomy. Let's see, I want to look at, well, speaking of photos, actually, here's an interesting story. Astronomers take, no, don't want any supplements. Astronomers take the sharpest photos ever of the night sky. This is actually using a very, very large ground-based telescope. We'll see that the larger a telescope is, the larger a telescope is, the better magnification power it has. Now, you know, a bigger telescope is going to collect more light. It's bigger, right? It's almost like, sometimes called telescopes light buckets, because the bigger they are, a bucket will collect more rain if it's larger than a smaller bucket, right? It's like that with telescopes too. So a larger telescope will make images brighter, but you don't realize necessarily it also makes them much sharper. And so what's been done here is people have used one of the Magellan telescopes, which I believe is in Hawaii, if I remember correctly, with a 21-foot diameter mirror. Okay? Much bigger, about twice or more than twice the size of the Hubble mirror. And it's allowing us to see features in the sky that are as small as, okay, there's a specific quote here, and of course you can't find quotes when you're trying to find it, so I'll have to search. Word done. There it is. Okay. We can see things that have an angular size of 2/100th of an arc second. Now we're going to be talking about angular size in astronomy. It's basically how big something appears in angular units, like degrees or something like that. Like you look at the clock on the wall from where I am, that's about 1/2 degree across of angular size. If you move the clock farther away, it's going to be smaller angular size, right? It's going to seem smaller. If you bring the clock closer, it's going to be bigger. So if you take a fixed object and you move it farther away, it has a smaller and smaller angular size. The best we can do from Earth's surface is about 1 second of arc of being able to see something that fine, that small of an angular size, which is the size of a dime about 3 miles away. All right, so with a very large Earth-based telescope, you could actually see a dime about 3 miles away. But what we're doing here is we're the equivalent of being able to view a dime more than 100 miles away. Or another way of putting it is you can see a baseball diamond on the moon with this ground-based telescope. Anyway, you'll see this is actually pretty mind-blowing because it's on the ground. And I just said a moment ago that you actually can't do better than about 1 second of arc when a telescope's on the ground. But here's a telescope on the ground. That's clearly doing a lot better than that. It's seeing much smaller features. Well, it's using special techniques that we'll talk about to be able to accomplish that. There's always interesting news coming from Mars. Like, for example, now, you know, there's 3 rovers, 3 of the things we call rovers on Mars. There's Opportunity, Spirit, and Curiosity. Curiosity is the big one that's rolling around about the size of a car. That size of a Prius, or basically a car, that's the size of a car. And it's rolling around there right now as we speak, doing all kinds of incredible things. But there are 2 precursor, smaller rovers named Spirit and Opportunity. You guys remember Spirit and Opportunity? Well, Spirit is unfortunately deceased. But they both lasted much longer than they were supposed to. They're solar-powered rovers, and they lasted because, actually the prediction was that these small rovers, Spirit and Opportunity, would die after about 6 months because their solar panels would be covered with this reddish Martian dust that you just can't get rid of. You can't get out of your house. That's why we're not colonizing Mars at the moment. It's so darn hard to get that dust out of the space bubble stuff. So anyway, so the prediction was that the dust would get all over the solar panels, and you know, without the solar energy, they're dead because there's no nuclear power on these rovers. But they keep getting hit by Martian equivalents of what we call dust devils, or sort of mini tornadoes, and they just periodically get swept off. So they've gone on 4 or 5 years beyond the initial mission. And Opportunity is one of the 2 original ones that still survive. Spirit is dead, Opportunity is still alive, and recently found what we call drinkable water on Mars. The whole Martian thing is really important for us because one of the subtexts of this course is the idea of where can life form. You know, we see life on the Earth, where else can it form? Well, we think any life we think we understand would require water. And we've known for a long time that there was historically water on Mars. But this is the important new thing. All those other discoveries of water on Mars, which were made over the years by rovers and whatnot, all involved regions where it was very acidic water, like water with sulfur, basically sulfuric acid-laced water. Okay? And acidic water, you know, we have no theory for life to form in acidic water. That never happened on Earth as far as we know. So although we've discovered lots of water on Mars, it's always been associated with acidic rock formations, indicating that, you know, even when this region was wet, it actually wasn't habitable, and you wouldn't have had, you know, microbes evolving because they would have been dissolved by the acid. It's just too harsh an environment. So the significance here is that just recently, a few months ago, we have discovered water that has a very reasonable pH. It's actually not literally the water itself, but what we've found, as it says here, is regions that have a type of clay that had to have formed in a non-acidic environment. And so basically there's an implication that there was, you know, non-acidic water on Mars. And then again, that opens the possibility that life could have evolved on Mars. We have not discovered life on Mars at the moment, but there's very good evidence that there is still water under the surface of Mars to this day. All right.